Alright, welcome to my tutorial. This is going to be for PLC 2100. I'm going to be doing an Autodesk Inventor tutorial, and since it is a PLC class, I'm going to be making a DIN rail. So this schematic I had pulled up on my phone, so you won't see it that much, and I also did a little test run through just to make sure I had my numbers right, so you didn't have to watch me do math. So you can see that test one down here. So we'll do new part. And what's different about this is that we won't be doing it in, normal Inventor. We're going to be doing it in sheet metal mode, which allows us to export the file as a DXF, which means we can send this off to a laser and they will cut it out for us. So we'll start our sketch. Go down here. I'm going to do just a 1 foot section because it's easy enough and you'll get the point. 0.98. So there we have our base of what will become a DIN rail slowly. And next I'm going to go into slot. Oh, 24 degrees. Make sure that's 90 so don't mess up our numbers. So there we have our first slot, and instead of making 18 of these things, we're just going to make a pattern of them. So make sure we have our geometry here. One to the left, the other to the right. Get our spacing right. Oh, another thing you can see here, if the spacing isn't the exact same, so if I do like 1.2, you'll be able to see there's a little bit of overlap here. If I put more on here, you'll be able to see that better. They're overlapping, which doesn't really matter because as long as you have them, correct, you can see it won't affect anything. It's basically doing two cutouts, but it doesn't matter, It doesn't really affect anything. You see I left the ends off here because when you do a pattern, if I wanted to kind of cut this part out, it would just shut the whole thing down, and we don't want to do that. So what I'll do is I'll just make an extra one down here to line up. And I will vertically constrain this because you can see this is blue right now and the rest is all black. The program doesn't know where this is at unless we constrain it to something. I'm going to go right in on the origin, which it still wants to be fussy, but that's alright. We'll just dimension that out of there. I'll have to check my schematic here to make sure I have the numbers right. This will be 0.98 as well. There. Now we're fully constrained here. The program knows what we're doing. We'll just finish this up here. There we go. And we'll horizontally constrain this guy. Oh, never mind. Vertical. Oh, I guess we won't. We're just going to leave that one there. Especially since this is just a tutorial, this isn't a really big deal, I guess. Normally, I don't know, in my test run this worked fine, but I guess not anymore. So next, what we're going to do, because you can see that the rest are nice, this one kind of sucks, we can split these, and this is one of my favorite things about Inventor. I'm sure the other programs have it, but construction mode, bang, bang, they're gone. Now this is a solid line here, and they're still here just to constrain the part and show what it is, but they're not going to affect anything over here. And we can do the same on the other side. Can dimension that nicely. And then we will constrain this one to the origin, so it knows it's lined up on this, x-axis here. Add our lines in. So you can see what I mean here. This side worked fine. The other one wants to be weird, so we'll split this one here. And all this does is, it's a solid line here, so we're just going to split it so we can kind of tweak them individually. So we'll construction, do that again. So there's the base of our part. We're going to finish our sketch. And next, usually from here we would extrude it, but because this is sheet metal, we're going to face it. We can face it like that, and you can see this is like pretty thick for a DIN rail. So sheet metal mode, it doesn't go by you're going to extrude it and you get to pick how much you're going to extrude it by. It goes by sheet metal rules and defaults. So I have mine to select right now to follow my defaults I have set. I can unselect that and I can switch to my default millimeter and whatever else, right? To change that, we're going to go into our defaults. Default, yep, use thickness from rule. We're going to change this because obviously they're at a different thickness, which I believe is 0.118 or 1 millimeter, or no, 1 millimeter, 0.39. That should be close. And now we'll go back to face. That looks a lot better. So direction, this is, I don't know, you can mess with this, you don't have to though. Okay, so that's there. And you can see that line that was being weird, it worked out, it's fine. So now that we have that, the next we're going to move on to our flange. This is a really important tool in sheet metal mode because it's basically the only way to extrude the side of something that is efficient and easy to use. So I'm going to come, also another thing is that it really does depend on what line you pick. If I pick here, it's going to go down. If I come back and do here, it's going to do the one I want. So we're going to take a front view here, grab this side as well. And important thing is your bend position. So right now I think we're on the default inside of reference plane. So I believe this is 98.98 from here to here. Inside of reference plane means that the bend will come up in line with that. You can go on the very outside and start your bend outside. I think for this we're going to go right in the middle though here so that the inside of this extrusion or flange lines up with our 0.98. I think that's what we want here. And our distance is going to be, make sure I got this right, 255. Take a look, looks right, good to go. So then if we look at it again, we can see it's slowly coming together, and we'll do another flange on this outside edge, and this one is going to be 0.2. And again, outside of reference plane, make sure that's selected. You can see how easily that will affect your part by changing this. So you always got to make sure you get that right on your measurements. So that's good to go. So this is pretty much all we really have to do. This is our entire part. But here's the problem. If we did want to send this off and make this into a laser cuttable part, what we have to do is I'm going to save this quick. I'm going to do 2100 tutorial. Good to go. So this has a name now, and what I'm going to do is I'm going to create a flat pattern. And what this does is takes all those flanges that we just made, and it's going to flatten it out. You can kind of see in this picture here what it'll do. So this is the flat pattern for our part. These yellow lines indicate a bend line, and this is something you kind of need. This is what you will export as a DXF. Let's see if I can do it here, if I remember how to do it. Okay, I don't remember, but this is what you use to send off to a laser. So what I'm going to add on to this tutorial is we're going to come back to home. I'm going to add on a schematic, which I didn't practice this, so I might not be great at it, but we should be all right. So here's our schematic, here's our paper, which these are printable, obviously. Really nice to have. So first thing, we're going to come in and bring our base in. And because I have this kind of window open here, it's going to automatically latch onto this. Otherwise, I believe you would have to select right here what you wanted to bring into the schematic. So I'm going to go flat pattern. You can see the view that it's bringing me is a folded view from this front side. So I'm going to go to the top. I'm going to rotate it. I'm going to go flat pattern. Okay, that just went all wonky on me. Okay, yeah, we'll have to go to the front. That's fine. Scale 1 to 1 doesn't make a huge difference. These are your different view styles. Again, don't make a huge difference. Just depends on if you want it to look pretty or not. So from here, I'm going to just bring this up, put it right in the middle somewhere. And something I like to do also is to leave a kind of like a home view of what the finished part should look like. Just so whoever's kind of messing with it can see what's going on here and what it, in case they can't figure out like, oh, which way is this supposed to bend. Just kind of nice to have on there. So from here, what we'll have to do, which actually I might scale this up just so we can see it better. Yeah, that's good. So we'll go right there, kind of make this look a little neater. Good enough. Alright, so then we're going to go to annotate and dimension. This is for if you are going to get this thing laser cut, you need dimensions on it so that whoever's going to have to bend it knows the dimensions of the bend and the actual part itself, which you can see right now. This is super tiny, nobody can read that. So what I'm going to do is go to, let's see if I remember this. Place view, is it here? Annotation. Edit layers, I think this is it here. Dimension. And wait. No, that's not it. Where's it at? Alright, yeah, I didn't practice this, so I'm a little... Okay, yeah, here it is. Right? View. No. What? Where's it at? Well, there was a way to make the text a lot bigger, but apparently I don't know where it's at anymore. I swear it was in here. Text. It's not in text. It's in a weird spot. Alright, if I can, I'm going to speed this up. I don't know how to use OBS. Klint recommended it. We're going to blame Klint for this if you have to watch this. So yeah, otherwise I'm just going to make a cut here. So once I find this, I'll come back. Alright, I think we've got it now. I did have to Google it. We're still going to blame Klint for that because this is obviously his fault. Anyway, okay. Fixed it. All we had to do, edit layers was not the right place. We had to go to styles editor and change our text here. And I realized in the version of Autodesk I use at work and only place I make schematics at, the option to do all that is right in here. Is why I didn't know what I was doing. So anyway, if you are going to be making schematics that someone is going to have to be bending, there's only a few things you really need. First is the actual size of the part so they can tell what's going on. And you don't have to dimension out all these every little crevice here. The only thing they need to know is where these bend lines are at. So I'm going to tell them 0.17, but primary unit, I'm going to give them an extra digit so it can be more precise. And I'll do this one as well. Give them an extra unit. And then I'll go from this top side, which I think you can go bottom to bottom or bottom up. So I could be having larger numbers as it gets further away from the bottom, but at the same time, they can just flip the part around and do the exact same thing. So it's not that big of a problem. So here we go. This is our fully dimensioned part, ready for the lasers, ready for bending, painting, whatever else. If you wanted to get it painted, you'd just say in like quantity 4 paint black. Just because why not? So you throw that up there. Okay, whatever. I'm not going to fight with the text size on this one because you already had to probably watch me fight the first one, so I'm going to do that. Or this is something else where you print it off and you just write on there so they know what's going on. So we'll save this guy. Yep. Oh, yep, that's fine, I don't care. You cannot save 2100 in flat pattern mode. Yes. Oh yeah, this is another thing, is that because our other page, I left it in flat pattern mode, you can't save it like that, so it's gonna throw a fight about that. So you can see it brought us back to the normal view, but we can open this right back up if we want to. So that is the making of the part along with a schematic. I guess I'm not sure if there's anything else really to look at. This is kind of cool. Going into view, visual style, you can mess with these. I like to do this every once in a while. I know there's an RTX mode somewhere here where you can literally turn RTX on. Ray tracing, that's what it is. You can turn that on, and I don't know. I did it one time and almost blew up the computer at work, so I don't really mess with that anymore. And yeah, that is my tutorial. Hopefully I didn't stutter too much and it was easy to follow. And yeah, I guess that's it really. Yeah, bye. See you later, alligators.